Today, we take the fact that humans can live and work in space for granted. We take for granted doing spacewalks. We take for granted that we can repair a Hubble Space Telescope. We take for granted that we can build an International Space Station. But we had nothing in our toolbox to let us know for sure that we could do that before Skylab.
The history of how humans came to live in space is full of ingenuity, passion, and sacrifice. The first pioneers to live off-planet are often forgotten. This is their story.
Skylab was just such a frontier moment. It transformed our understanding of what is possible, what can be accomplished in human spaceflight. It's an amazing story. It's a story unlike any other.
If man goes to the moon and then comes back to Earth, then what will man do? Is he just going to sit down and say, hooray, yay, we made it? Or is he going to say, there are a lot of things that can be done in space. Now let's go get together, find out how to do that.
After the success of the Apollo moon program, its mastermind, German rocket engineer Wernher von Braun, sets his sights on a lifelong ambition, a permanent human presence in space.
We expect to build a giant satellite station 1,075 miles above the surface of the Earth, placed there to study the universe and provide a launching site for the exploration of the universe, the planets, and the moon.
Von Braun has his eyes on the stars.
It would become known as the von Braun paradigm. Achieve access to space, learn to work and live in space, and then to move on to other heavenly bodies. And it's really that flip that makes people like Kennedy enamored with von Braun. He's a salesman. He knows what he needs to do to get this done. He's got a blueprint for space travel and turns something that had been science fiction into more of a scientific reality.
So people understood the importance of a space station. Once we've used these systems, once we've used this technology to go to the moon, let's use it to establish a foothold in Earth orbit as well. The dream was Apollo without end. So now this huge national investment in putting humans on the moon has also become a huge national investment in developing the foundations of a space station program.
My gracious, this universe is going to get really huge, and it's going to get populated. So how can I then be a part of that? We're going to put up NASA's first space station.
Von Braun's first step is to suggest using Apollo-era hardware to build an orbiting laboratory. He calls it Skylab.
Skylab was the next logical step. Let's take the technology from Apollo and let's apply it in new and diverse ways. On the one end, you're going to have the Apollo Command and Service Module, the spacecraft to transport the astronauts. This becomes your Skylab taxi. At the other end of the Skylab, you're seeing the large cylinder. This was the rocket stage. That becomes the living quarters. That becomes the house. The other piece is the Apollo telescope mount. Cameras, the telescopes for Skylab's observatory, and that has its heritage in the lunar lander. Those three things give you the story of how do moon landings turn into a space station.
It was such a stretch of the imagination. It was sheer fun, but a whale of a lot of work.
Skylab, this country's first space station, will be operating in Earth orbit for about 8 months. It will serve as working and living quarters for 3 sets of astronaut crews for flights from 28 to 56 days.
The most important immediate thing we need to know is, can man live and work effectively and normally in space for long periods of time? We need to know what happens to man in weightlessness, whether it's dangerous. If it's dangerous, What countermeasures can we apply so that we'll get through those days and perhaps in the future fly very long missions?
Skylab was a very ambitious project. Over the course of its life, the plan was for it to accomplish great science and to learn about the microgravity environment.
How do you prepare for weightlessness? If you're going to work and be in space, how do you handle tools that you're going to work with? And so one of the guys said, "Did you ever watch your wife swim underwater?" We said, "You betcha." He said, "What did her hair do?" It just floated. It just floated in the water. Ah, that may be a clue to weightlessness.
The engineers built an experimental tank to try and replicate the conditions of space.
Von Braun's secretary was named Bonnie. So I called Bonnie and I said, "Bonnie, we have what we think something that the boss would be interested in seeing." She says, "Dr. Von Braun would like to get inside a pressure suit and go underwater himself. This is the guy." You bet, we were nervous, but we just knew that we thought we were onto something. And so did Von Braun. Von Braun came and says, "Ja, tis gut, keep going, keep going." We now had a functioning kind of environment. If you can train underwater, as long as you have air, then you're good to work for an extended period of time to simulate the weightlessness environment of space. We were now developing a real asset as far as training.
The place is NASA's Marshall Space Flight Center, Huntsville, Alabama. Located here is a 75-foot diameter tank filled to a depth of 40 feet with 1.5 million gallons of water. It's called the Neutral Buoyancy Simulator. Placed inside the tank are full-size sections of the Skylab space station.
The plan is to repurpose the third stage of a Saturn V rocket that launched Apollo into a huge cylindrical spacecraft with a habitable volume 3 times the size of a Greyhound bus. A simple idea, but fraught with challenges.
How do you make a space station livable?
How do we need to establish that so human beings can be comfortable, productive, and to accomplish the job that we need them to do?
We need to worry about more than just the keeping them alive. We need to worry about keeping them sane, keeping them happy. They've got to have a window. You cannot send these people up there and expect them to not be able to look out the window. Okay, not great from an engineering standpoint, but we're going to poke a hole in the side. From a culinary perspective, it is a fine dining establishment. Skylab was certainly the high point of anything that they had flown thus far. I think there are some things with Skylab that have not been matched since.
As Skylab neared completion, the Soviet Union caught the Americans cold and launched their own space station, Salyut, before their rivals.
Есть подъем.
Salyut was a big technological achievement, a flying laboratory equipped with more than 2 tons of scientific instruments, and it was the home of the crew of 3 cosmonauts.
На работу в космос. Георгий Добровольский, Владислав Волков, Виктор Пацаев. Они готовы к подвигу.
So that was the first time that cosmonauts actually lived in space.
Part of the cosmonauts' mission was to rekindle Soviet pride in space after losing the lunar race.
One of the benefits from Salyut was the ability to show TV.
The entire Soviet community was attached to the first crew aboard first orbital station. Now cosmonauts were basically visible by everybody, every day.
Now they had their own heroes, writing new pages in space history.
The mission lasts for 24 days. Dobrovolsky, Volkov, and Patsayev spent more time in space compared with any human being on Earth. They were excited because that was end of the most successful space mission in the Soviet cosmonautics, and they were coming back as heroes. They didn't know what was happening in the spacecraft. And from that perspective, recovery crews were ready to act for any type of events. They reported seeing the spacecraft, opening the parachute. They ran as fast as they can. A few of them knocked on the window. There was no response. They opened the hatch.
They got a shock.
They saw bodies.
3 lifeless bodies.
Covered by blood, no movement, with no signs of life. They laid them on the ground. Dobrovolsky were still warm.
Now, it was a national tragedy.
В тот день советский народ провожал в последний путь героев космоса. Георгия Добровольского, Владислава Волкова, Виктора Пацаева.
They were laying in state for several days, and the crowd passed by their heroes, so it was a mournful tragedy.
The loss of 3 men who were almost the members of families of every common Soviet citizens for 24 days. That was shock. Absolute shock spread across the Soviet Union and all other countries across the world. In the United States as well, President Nixon asked directly astronaut Thomas Stafford. He represented the United States, White House and NASA, and all American astronauts on the funeral.
An investigation into the accident determined an air pressure valve malfunctioned during re-entry. All 3 men suffocated within 2 minutes.
The failure of that valve took the life of the crew.
What we ultimately find out was that it was not anything that is that's a permanent red light for long-duration human spaceflight. The challenge of Salyut is we felt good about this.
Dobrovolsky, Volkov, and Patsayev were the first human who lost their lives in space. Unfortunately, somebody must die for others to live and continue exploration.
Finally, after 7 years of preparation, the Skylab workshop was ready to launch.
The most powerful rocket ever built. I mean, up to that point, even today, we have not seen the equal of the Saturn V. Has just sent humans to the moon, has made history, has accomplished something unimaginable, and for the last time in history, a Saturn V, 363 feet of raw power, is sitting on the launch pad, ready to roar away from the Earth.
13, 12, 11, 10, 9, 8. We have ignition sequence has started. 6, 5, 4, 3, 2.
The engines light.
And we have liftoff.
Saturn V departs from the Earth's surface, roaring up into the sky. If you are there watching it, it is amazing.
The Skylab lifting off the pad now, moving up. Skylab has cleared the tower.
While the sheer raw experience is amazing, the telemetry is concerning.
There was a problem.
This is Skylab Control. Preliminary telemetry indications are that there could have been a malfunction.
We were monitoring and we started sensing that there was some problem.
These malfunctions were indicated to have occurred 1 minute and 3 seconds. after liftoff.
Something has happened here, and nobody's entirely sure what.
Nobody knew. The Cape didn't know. Houston didn't know. Washington, D.C., NASA didn't know.
And to lose Skylab at that point would have been a financial catastrophe.
You lose potentially, $2.5 billion investment.
But it was more than dollars cost. It was pride cost. Why did it happen on this launch? Where did we fail?
Everything they had done going to work for the last 7 years had been preparing for the day that this Saturn V leaves the ground, and in 63 seconds have we just lost everything that we have put into this moment just like that.
This is Skylab control. Internal temperatures ranging from 170 to 190 degrees Fahrenheit. External skin temperatures are running between 240 and 300 degrees.
The thermal environment is insanely wrong. There's no way it should be this hot. It's not designed to be this hot.
Skylab was fitted with a meteorite shield to protect it from heat and debris. As the rocket reached its maximum dynamic pressure, this layer was ripped off.
It exposed a section of the external skin of the habitat directly to the sun. We had a habitat up there, but it basically was not habitable.
And there's no electrical power.
Here in the control center, the problems associated with the failure of the Saturn Workshop solar panels to deploy are being discussed.
Skylab had 2 giant solar panels that were supposed to come out on either side of the space station to provide the electrical power. With the shield gone, one of those just deploys immediately. And you can think about a giant wing coming out in the airflow as the rocket's taking off. It's torn off.
The other solar panel had also tried to deploy, but oddly enough was prevented from deploying.
A small strap of metal from the shield wraps around the other wing. It's still there. It just can't deploy.
Now that's a good thing because it saved that panel.
That one little strap of metal saved the Skylab program.
The planned 28-day mission is not possible without deployment of the workshop main solar panels.
Now there are 2 problems that have to be dealt with before there can be any discussion of people actually going and living on this space station. We've lost our heat shield. So the thermal environment, the heat inside the space station is out of control. We don't have our electrical power system that we're going to need to be able to do the science that has to happen to make this all worthwhile. How do we fix Skylab?
The first Skylab crew are due to launch the next day. Their mission is delayed by 10 days.
NASA enters a 10-day period of its history unlike any other time in its 60 years.
What kind of fix would we come up with in order to make it a habitable space station?
10 days. 10 days to innovate, develop, qualify for flight, and pack solutions to 2 huge problems.
How do we go fix it? How do we go fix it?
24-hour work days, working shift work. They were sleeping at work.
Mind-boggling. I don't think anything like this had happened before. I don't think anything like this had happened since.
The pressure was tremendous. Failure here certainly was not an option for us.
All the NASA centers were working on it. All our contractors were working on it and taking an active part in the discussions and the decisions that were made as to what's wrong with the workshop and how we're going to fix it.
You go to the beach, you want to be cool on the beach, you take an umbrella with you. Let's give Skylab an umbrella.
We've got to have something that can be put into the command module that can be taken to Skylab.
Skylab had a couple of small science airlocks. We're going to take one of those airlocks, we're going to stick an umbrella out of it.
So the parasol had to be created from nothing.
You had a room full of seamstresses working on sewing this thing, getting it done. Then you see them getting it packed up and rushing it out to get to the launch site.
They were down to the last 30-minute extension as the parasol, packed in the flight canister, was loaded for transfer to Cape Kennedy. Hopes ran high that the parasol would do the job. Attention now turned to the astronauts who would attempt to put it in place.
So the first crew of Skylab is Pete Conrad, who walked on the moon on Apollo 12, Dr. Joe Kerwin, the first medical doctor in space, and P.J. Whites. They have been training for years for this mission. Oh, and now you have 10 days to train for the real mission. We have a broken space station. Can you fix it, please?
They must find a way to cut the metal strap entangling the solar panel using the tools they'll have in space.
Schweikert spent many hours underwater simulating techniques for fixing the solar panel.
We demonstrated that just by tightening up further on the cutters, the large cutters that we had at the end of the 25-foot pole, that we could also cut through the strap using those cutters. And we were able to demonstrate underwater so that we had high confidence that the crew would be able to get the job done.
Somehow, on May 25th, those 3 men were in that space capsule with the solutions to save Skylab packed on their spacecraft, ready to go. They approach Skylab. It's beautiful.
Callie, the Skylab. We got her in daylight at 1.5 miles, 29 feet per second.
But at the same time, it's visibly wounded.
Okay, Houston, the meteoroid shield area is solid gold.
Roger, copy.
Suspected solar wing 0 is gone. Completely off the bird. Solar wing 1 is in fact partially deployed.
They're able to dock, they're connected. The next step is opening the door of a spacecraft that has spent the last 10 days in orbit outside of its temperature constraints, hotter than it's allowed to be, and hope that you can breathe the air. How quickly can we leave if we can't stay? They go inside. They find, thankfully, a breathable atmosphere, but a dark and hot space station.
You had to lower the temperature of the workshop in order for it to be inhabited.
Commander Pete Conrad deploys the solar parasol through the airlock.
Some 4 hours after the operation began, the thermal parasol was deployed. It was then placed in position close to the workshop skin.
And then you have the umbrella doing its umbrella thing. I mean, everything is working.
We can see the ends of all the rods. It's completely free of anything. There's nothing hanging it up.
Something has gone right. This is turning our way now. It's a great moment, but is it going to bring the temperatures down? And it's not an instantaneous thing.
It took about 2 revolutions of Skylab before temperatures began to fall. Projections showed that if the present trend continued, the workshop would be below 100 degrees the following day.
Pretty soon and pretty quickly, they can feel that the atmosphere is becoming a little more livable. We have a space station, we have a crew aboard it, we've gotten the temperature under control, still have that stuck wing, you still don't have the electricity.
We've got to get that other solar panel up so that we've got power.
How do we free that solar panel and save this mission?
Make the key parts right where all those wires are. See them hanging out that upper vent. If we don't get it off there, we ain't gonna get it up, right?
The astronauts climb out of the airlock and underneath the Apollo telescope mount until they are facing down the trapped solar wing. Unable to move any closer, Kerwin must use a 25-foot pole to try and hook the jaws of a pair of cutters onto the metal strap and cut it free.
We were doing a follow the leader on our hardware underwater in neutral buoyancy. If they ran into some kind of a problem, we could immediately say, hey, we've got a recommendation for you, try this.
Let me direct you, Joe. You can pull the pole back. Wait a minute. Hey, that's a beautiful place to cut it, right? See? Yes. Yeah, you're in the right area if you get through those wires. Just take your time.
The problem existed in areas where there had never been any plan at all for an astronaut to go on a spacewalk. There were no handrails to that area. There were no foot restraints in order to be able to anchor his body to where he could do work. It was almost like trying to ride a huge elephant with no saddle. Nothing out there but smooth skin, except for this one solar panel down there that was now in dire need of some help.
Listen, how about unhooking that rope back there? Hey, how about if you unhook it from the cleat? And I want you in a position to pull on the right rope while I'm holding it in place. Because I can't do both. Okay. Okay? Just a second.
That emotion and tenseness of when that pole with that cutter on it was being extended, and you heard the communication between the two astronauts was just almost indescribable.
You know, the best chance you have is as close to the base of this ass panel. That's where it's the narrowest. Is that right? But there's a wire bundle there. Yeah, I got the pole. Okay.
Pressure-wise, we were at a peak.
Oh, no, you're in front of it. Now you're behind it. You're still behind it.
We've got to make this happen.
Good, that's the place to work. Yeah, I'm sure I am. Now pull towards me.
Pete Conrad reported, strap is cut. Man, you could just breathe. It's like a huge weight that had been sitting on your chest had just been relieved. Solar panels came down. Now we had power. We could see very quickly the power that we had just fixed was going to be sufficient for us to complete the mission. And the flight crew had trained so well, so hard, in neutral buoyancy, they just clicked. They just made it work. And the sweetness of success, oh, how sweet it was that day. Dr. Von Braun, he believed in us. He said, yeah, keep going. Oh, how good it feels. We made it.
That spacewalk is a major moment for the future of American human spaceflight. They have just proven for the first time that you can do work, meaningful repair work, outside of a spacecraft that you didn't even plan for. They have saved the program. They have saved the United States' efforts to prove that you can do meaningful science in space. With the Space Shuttle, Skylab, the International Space Station, all rest on that moment.
The first Skylab crew returned to Earth after a record 28 days in space. In an historic moment of solidarity between U.S. and Soviet superpowers, President Nixon and Premier Brezhnev welcomed the astronauts home.
Because it wasn't just a NASA thing, right? This was an America thing. I mean, the nation was invested in these few days of saving this space station. It was a big deal for everybody. So now the second crew is getting ready to launch, and they're launching not to a broken space station, but to a fully operational space station.
Only in the last few weeks, in the time of Skylab, have we really begun to exploit and see the potential of man operating in the near-Earth environment.
The second crew came up. They worked at a tremendously heavy rate.
They love it. They love not only being there, they love the work. They are accomplishing incredible amounts of research.
The second crew conducts pioneering experiments on the effects of microgravity on the human body and mind. They observe the Earth's changing weather patterns in more detail than ever before and carry out groundbreaking science, including photographing erupting solar flares.
At the end of the mission, they come home, they have accomplished 150% of their mission objectives. The NASA press release dubs them the super crew.
The crew spent 59 days in space, doubling the previous mission's record. The third Skylab crew prepare for the last scheduled Skylab mission.
You know, one of the tremendous stresses that the final Skylab crew had is they had incredibly big shoes to fill. There was a big shift in the 1970s from astronauts who were just rugged test pilots to people who could live and work and do technically demanding tasks in space that required tremendous medical and scientific background. Their predecessors had done miracles.
So on the third crew of Skylab, you have Commander Jerry Carr, you have pilot Bill Pogue, and you have science astronaut Ed Gibson.
The commanders of the last two missions of Skylab, they were the third and fourth men to walk on the moon. How much experience did this crew have in space? Zero.
This is a last opportunity. It's a last opportunity to do research in space. It's a last opportunity to prove just how valuable a space station is. The second crew accomplished 150% of their mission objectives, so clearly there's a lesson to be learned here that we didn't assign them enough work.
The crew docks with the space station.
One of the things that Skylab was really interested in was space adaptation syndrome, a very nice way of saying throwing up a lot in space.
And so it was essential to get all of the information about how the astronauts were coping. Were there ever any times it was difficult for them? What was that like? They needed the data.
The pilot, Bill Pogue, known as Iron Belly or Iron Ears, you could throw a plane around and never get sick.
Bill Pogue gets in space, he gets sick.
He was vomiting, he was not feeling good. And the crew decided not to tell mission control.
It's the beginning of the mission. They don't want anybody worried. We're gonna be able to go in, we're gonna be able to do work. We don't want anybody to think that these rookies can't hack it.
One of the fundamentals of a successful mission is you have to have good communication between the astronauts and ground control. But this was threatened almost from the outset.
What they forget is that their recordings are downloaded at the end of the day, and this is heard on the ground.
A guy with the insensitivity to motion that Bill's got to have problems, I think there's something else involved here. People better start looking around a little more and get off this motion sickness kick.
This is a big deal, right? Because this is not only an astronaut got sick, this is hiding data, right? This is hiding information that's vital to the future of the space program. It's also just, you know, not being honest.
It got picked up by the media. So the New York Times had a headline that the Skylab astronauts had been reprimanded in their first day. It's not a great start. You disappoint your boss and get chewed out, and then, you know, everyone knows about it.
Not only did the crew have to overcome this problem of not reporting the illness and Bill being ill, the program was heavy loaded really early in the mission.
Because of the success of their predecessors, this crew had to do more and more and more. So it seemed like the deck was stacked against the crew. The work kept piling on.
What happens pretty quickly is they start falling behind. And so the ground decides to help.
Mission Control begins to schedule the crew's tasks down to the minute.
They're sending up the instructions on a ticker tape. They have a printer that's just printing out a long feed.
But by the time they've read the ticker tape, they're already behind schedule. Feels like you're a monkey who's just being told what to do. You're going through the motions of your master.
They were stressed. You could hear that in the voice.
One explanation for this conflict between the crew and mission control is what psychologists call an us versus them mentality. The folks on ground control, they get to go home at night. The folks up in space say, but you just don't get it.
Desperate to keep up with the relentless schedule, the crew starts to skip rest days.
The astronauts had simply no downtime.
Performing more research, performing more work.
Mistakes began to be made.
Out of the consoles on the ground, we knew that it was not going well.
If they've done it already, that's fine. Whatever they've done, they'll take.
The crew was just not performing to what was expected of them.
Okay, this is a lot. We need to find, efficiencies where we can.
Every day, all three of the astronauts had to attend a briefing with Mission Control.
We don't need to all three be on the radio every time home calls.
It was Polk, Carr, Gibson, Polk, Carr, Gibson, rotating through the astronauts. And this was working fine, except one day, no one showed up.
Skylab Control Houston at 13 hours 18 minutes Greenwich Mean Time, standing by now for acquisition with Skylab 4 through Madrid.
And the folks down at Mission Control were, wait a second, what's going on? Why aren't they communicating with us?
This is Skylab Control.
All three of them thought that somebody else was on the radio.
And so that did create the situation on the ground where it was misinterpreted as they turned off the radio.
These guys are sending us a message.
Sometimes even accidental instances, something that wasn't intentional at all, can be the trigger to really let conflict come out. And that's what happened with this missed schedule, this missed meeting. It became the event around which finally there was able to be some open communication.
At this point, these are two teams that have been working together that are frustrated with each other. This is marriage counseling in space.
We're going to look especially hard at areas where we think possibly that you can help us, or look for ways on orbit in particular areas that you may not be aware of where it will help us in scheduling.
The astronaut Ed Gibson said it was the first sensitivity training in space.
I think it'll help you understand our problems a little bit better.
Okay, that sounds fine, Dick. We can try to think up, do whatever we can to help the situation.
So that was a turning point. That was a peak in a graph.
And Bill, are you up in a speaking configuration now?
Let's check. How do you read?
Reading you loudly, a little bit of crackling, but why don't you go ahead and readjust the one on you and the ground. Seem to be in disagreement on who's responsible for some of the mistakes made, and how do you feel now? Over.
One of the things that the commander said was, listen, if we were on Earth, you would not ask us to work 84 days solid, 16 hours a day without a break. That's what we're being asked to do up here. It is untenable.
We're still dedicated to accomplishing all of this, but we've got to do things differently.
We have to make adjustments in the schedule. We have to allow flexibility.
Mission Control said, okay, we hear you. Here's what we need done. You guys decide when to do it, in what order, and what time. And so NASA gave the astronauts the most prized gift they could have, autonomy. And so, as a result of that, it became the longest mission to date.
I've got the honor of congratulating you guys on transitioning from the first rookie crew to the most veteran crew in the solar system. And as far as we're concerned down here, you're doing an outstanding job all the way. I think we've probably sandbagged you on a couple occasions on schedules that you're aware of. Just keep up the good work up there, stay loose and enjoy it. I think if you keep going the way it's been going, why, it'll be one of the best missions we've ever seen.
This mission showed us that by giving astronauts greater reign of what they're going to do, you can have a more successful mission. It creates the foundation for the International Space Station, where it's not enough just to be tough, to have the right stuff. You also have to be interpersonally sensitive. You need to be attuned. You need to be a good communicator. You know that in the stresses of space, conflicts are going to arise. You just have to learn to deal with them. And so more than any other mission, this mission laid us on a course not just to be able to travel into space, but to really be able to live in space.
How would you like the people of the world to think of your mission, the last Skylab mission? Over.
I think I'd like people to think of our mission as one where three guys went up and set up housekeeping and tried to live a normal life in space to show that it could be done, that man can live a normal existence in space, and that he can accomplish a great many things while he's living up here that just can't be done on the ground.
The crew returned to Earth after living in space for a record 84 days. They proved that with the right training and management, civilians can flourish in space.
They end up coming home very much as much a super crew as the second crew was.
After these 3 successful crewed missions to Skylab, we build an incredible amount of information about how the human body responds in the microgravity environment.
Skylab showed that not only can a human being survive and thrive in space for that period, they can accomplish incredible things while they're there.
Now I'm going to turn this little rascal loose. There. Okay. And I'm going to use these 2 soda straws in order to provide the forces that I need.
Skylab proved that some astonishing scientific discoveries can only be made off-planet. It revealed that valuable astronomy and Earth observations can be conducted from space. But the most enduring legacy is the proof that humans can live and work in space.
When the third crew left Skylab, it's continuing to orbit the Earth. At that point, NASA's expectation is that without anything else happening, Skylab should stay up until well into the 80s.
And at that time, the space shuttle program was in development, and the thought was to deliver a propulsion package to the Skylab and allow it to be boosted to a higher orbit and then used later.
Because that's going to happen. We're going to send shuttle up and it's going to visit Skylab.
It was understood that one day we could reuse Skylab.
But the space shuttle program is experiencing delays.
At the same time, the sun that they had been studying is more active than anyone had anticipated.
The sun has an 11-year cycle of really heightened activity, a lot of erupting solar flares. At the time period when Skylab was in orbit and awaiting rescue by the shuttle, solar activity was an increasing part of that cycle.
This unexpected spike in solar activity causes Skylab to drop out of its orbit.
And the realization is made that Skylab is going to come down sooner than anybody expected.
This very large object, over 100 feet long, weighing 77 tons, it's going to be re-entering the atmosphere, and there's a good probability that parts of that will survive and impact the Earth.
This is a full-up house in space that's going to be coming down. The places on this planet where people live, at some point, Skylab is passing overhead.
Skylab was definitely coming down sometime in the middle of '79.
NASA had to respond to save Skylab again.
There very much was a team that was actively working to control Skylab to get it ready to come in.
Roger, sir. We have you scheduled for an ASAP playback at 15:11.
How do we control the re-entry of Skylab in a way that it doesn't endanger lives on the ground?
There was very limited control. Traditionally, any sort of spacecraft to bring it in, you're going to have a retro burn. You're going to have an engine, a thruster that's going to fire to slow it down. Skylab didn't have retro burn. What they did have was they had control over its orientation.
Okay, point 1, 2, 4, 3. Point 2, 0, 0, 1.
Well, the best case scenario would be to bring Skylab down in an unpopulated area. However, there's very limited chance to control that. The worst case scenario could be that Skylab could plummet onto the top of New York City, Paris.
Somebody tells us, oh, by the way, there's a giant 76-ton house in space and it's going to be crashing down. I think it's very easy to jump to the, well, I hope it doesn't hit me.
Where is this gonna come down? Where is it gonna fall?
It's kind of almost like watching a horror movie in that it's scary, but there's a fun to the scary.
I heard of people in the United Kingdom that were outfitting a bunker, an underground bunker, to go into and live.
You see people buying hard hats, their Skylab crash protection helmets. Liza Minnelli apparently didn't leave bed for a month. The sky is falling.
Tango 28.8 south.
Vehicle currently passing over the eastern part of the African continent. as Skylab will make its final approaches over the United States this morning.
The decision was made to put Skylab into a tumbling motion. Because after we lose control with the solar panel separating and no power, it wouldn't matter because it's already tumbling.
Last tracking indicates the vehicle is tumbling very steadily.
NASA commanded the tumbling to bring it down over an ocean, over an unpopulated area. The confirmation that it has impacted the Earth partially comes from no tracks. It doesn't exist.
You've got control, you've got command up until that moment of interface, up until it goes into the atmosphere, and then silence. We've done all that we can, but we're still waiting for that final word that everything's okay.
We really didn't get indications until an airline pilot flying near Perth, Australia, saw it.
We have a sighting from Esperance, very bright. They observed it for about 25 seconds. They estimated anything between 20 and 50 pieces.
What we didn't know yet was anybody injured in Australia?
Preliminary estimates by NORAD indicate that Skylab has impacted in the southern Indian Ocean, southwest the coast of Australia.
Reports came in about pieces being found and no reports of damage or injury.
Finally, once again, for the last time for Skylab, it's all paid off.
It looks like it's probably re-entered.
Interestingly enough, though, the government of Australia did fine the United States government $400 for littering.
Without Skylab, we wouldn't be as far as we are today on the International Space Station, or as close as we are now to living on the moon and Mars.
It's the turn now to what do we need to do to live off the planet for long periods of time and to achieve the great science that can be conducted nowhere else.
The world is about to enter a golden era of space habitats. There's the International Space Station that's up there today. China just launched the first module of a new space station. Russia is working on a future space station. NASA and international partners are preparing Gateway that will be a space station in orbit around the moon. You're gonna see habitats on the surface of the moon as astronauts are going for long duration missions there. And finally, you know, ultimately, the habitats that we're gonna see on the surface of Mars. We are going to leave this little blue marble that we live on, and we're going to begin to make homes in our cosmos. And when we do, the step, that first toe dipped in the water that made us homesteaders of space, was Skylab. I'm getting used to knowing how to fly. When I was young, I used to fly and dream. Up ways so high and easy it would seem, as if Earth wheeled and slanted, and not I. And now it's real. We move that way at will, like dust motes in a sunbeam. Push away, drift down your own trajectory, tumble, play. And who can say what moves and what is still? In this high, sunlit ship, the laws of space, height without vertigo, mass without weight, entrain our nerve waves to their easy pace, as if this rhythm were our native state. What if man were an exile from the sky? Are we perhaps remembering how to fly?